Welcome back to day 7 AWS series. Today we will be discussing about AWS Secret Manager. Hard coding secrets like password, API keys and database credentials directly inside the application code is one of the biggest security risks in modern cloud environments. Anyone with access to this code base can potentially see these secrets, and once leaked they are very hard to rotate or control. Right? So this is where AWS Secret Manager comes in. Right? Instead of storing the credentials in your application code, right, you will be storing those credentials in the secret manager. Right? Your application then fetches these secrets dynamically at runtime using IAM permissions. In this way, secrets are encrypted, centrally managed, and can be rotated automatically without changing the application code. Right? Whether it could be an EC2 instance, containers, Kubernetes, or RDS. All services can securely access the same secret in a controlled way. So in short, no hard-coded credentials, centralized security, encryption and rotation built in. Right? So AWS Secret Manager helps you build safer, more scalable and production-ready cloud applications. Very simple, right? So if your front-end application wants to connect to the back-end database, basically it needs a secret in order to connect to that back-end database. Should we hard-code the credentials on the application code? No. It's not the best practice in order to hard-code the credentials on the application code. It should be always stored in AWS Secret Manager and then using an API call, access those secrets on the fly. Right? So again, if your application needs to access this particular secrets from the secret manager, and IAM permission with the proper defined policies should be attached to that particular resource or a service. Right? So this is known as AWS Secret Manager. Let's move on. So AWS application uses different kinds of credentials, right? And managing them securely is critical. Right? So with Secret Manager, you can store and manage multiple types of secret in one central place. Right? The first one here is RDS credentials, which is nothing but RDS database, relational database. You can store your database username and password with built-in support for automatic rotation. Next, you have document DB credentials, right? Used for MongoDB compatible databases. This also supports automatic rotation. For analytic workloads, Redshift credentials, securely manage and data warehouse user access, and again with automatic rotation. Right? You can also store other database credentials where rotation may be handled manually depending upon the database type. Right? So beyond databases. So we are discussing all these things with respect to databases. Can we store any credential beyond databases? Right? So yes. Beyond databases, AWS Secret Manager supports other types of secrets like API keys, access token, and application secrets. Right? Application requests secrets securely at runtime, and AWS Secret Manager returns encrypted value based on the IAM permissions. In short, AWS Secret Manager supports database credentials, external service secrets, and generic secrets, all encrypted, centralized, and securely managed. Right? Understood? So these are the different types of credentials that what we could store in AWS Secret Manager. Right? So moving on with. So how do you store a credentials for a RDS? See, when you are creating a RDS, you will be getting two options. Whether this particular secret, that is the master credentials for this particular database, are you going to manually add those secrets? Right? Are you going to manually create those secrets? If you are going to create those secrets manually, it will not be stored in a secret manager, right? So which means that you need to go back again to the secret manager, create the secret and add those credentials over there, right? We have a second option over there. We let AWS itself, like RDS itself, to create its own credentials and manage in AWS Secret Manager. So it automatically creates some secrets and it will sync those secrets into the AWS Secret Manager. The first use case that we are studying over here is, so this is the one. So first we will create the particular RDS. Once we create the particular RDS, so here we are saying password automatically generated and stored. There is an option for over here, managed by AWS or managed by AWS Secret Manager, right? So this I'm explaining with respect to RDS, right? So if you are creating an RDS server, if you are creating a database server, this mainly needs a database credentials, right? So while creating that particular database, there is an option where you need to give the master credentials for the database, right? So you have two options, right? The first option mainly corresponds to managed by AWS. Automatically the secrets will be created and those secrets will be stored in your secret manager, right? So AWS automatic actions behind the scene, what it does, it creates a database user master key, generates the password, and it stores these two details automatically in the secret manager, right? So once the database is fully up and running, you can go to the secret manager and check whether that particular secret has been created, right? So you can also see that a rotation will be enabled, right? So in some cases rotation will be disabled. Make sure that the rotation on that particular secret has been enabled or not. Again, is it mandatory to enable the rotation on that particular secret? It depends on your project, right? If you want that particular secrets needs to be updated, right, quite often, like every 30 days once, you need to change your secret. Like to give you an example, we are using the ATM pin numbers, right? So at some point of time, the banks itself will send out a notification stating that this particular secret, like whatever the pin that you have given, it's been the same for longer duration. Please change your pin. Why? It might be compromised. In a similar way, so if your project demands, right, then you can go ahead and set this rotation as well. So by default, automatic rotation will be enabled on the RDS server? Yes, for some databases, as soon as you select a managed secret, right, automatically the rotation will also be enabled, right? So that you can verify in your secret manager. We will see through it in a demo session, right? If rotation is not enabled, definitely we can go ahead and enable the rotation, right? So we will discuss on single user or multi-user over there, right? This is how the secrets are created and managed with respect to the database, right? So one thing that you need to understand is, suppose we have created a particular database, right? This master credential also you have asked AWS in order to go ahead and create this particular credentials using AWS managed secret. Now at some point of time, you want to create one more user onto that particular database, right? I want to provision one more user onto that particular database. Definitely yes, I can go to AWS Secret Manager, select RDS, give the username and password, and select the corresponding database, and I will go ahead and create. But the thing that you need to note over here is, Secret Manager will not go ahead and create the user in the database, right? It will only create those secrets and it will map those secrets to that particular database. That's it. So suppose if you log into that particular database and you are trying to do log in with that particular user that you have created, it will show user not found. Why? Because Secret Manager will not go and create the users in your database. The first thing is you need to create that particular user, and then you need to come to the Secret Manager, create the corresponding user in the Secret Manager, and select that particular database. And again, there are two aspects to it. Assume, like if you don't want to enable automatic rotation on that particular user, right? I don't want to rotate the secrets for this particular user, then it's fine, no issues, right? So automatically, like you will select that particular username, you will select the password, you give the password and that particular username and password for which database you will select, and you click on done. That's it. But second use case, assume you want to rotate the credentials, like if you want to update the secret of that particular user, right? Then you need to have, like, that Secret Manager needs to have access to that particular database in order to update the secrets. Again, it is not gonna create the user, right? If you enable the automatic rotation, assume you have enabled the automatic rotation for after 4 hours, you need to update the secrets after 4 hours. What AWS does at the background is it connects to that particular database with the help of master credentials, right? Again, if you don't have a master credentials, or if that particular user whatever you are creating is not able to connect to the database, again it fails, right? You need to make sure that whatever the user that you are creating should have access to that particular database, right? So at the background, what it does, it connects to a particular database, it gets inside the particular DB, and it updates the password, right? It does a rotation using a lambda function, and it also updates the password in your database. It is not gonna create that user, right? It's just updates the user if you enable the automatic rotation, right? So this is what it happens, right? We will see through it in the demo session, like how we need to enable this and how we need to go through this. So this is all about your database credentials. Similarly, for all the other respective databases, you can follow the same way, right? Let's move ahead. So here, the second use case that I am showcasing is the other one. Like, see, I don't want to create the username and password. I don't want to select the managed credentials. Instead, while creating the RDS, I will give the username and password. I need to provide the credentials for this particular database. I don't want AWS to take care of this activity. Instead, I need to do that. So at that point of time, you will select manual. You will input the username and password as shown over here. The first step, create RDS. While creating the RDS, so credentials managed manually, you will select this option. You will enter the username and you will enter the password. Now, does the secret automatically get synced in the secret manager? No, right? You need to manually go to the secret manager, create a secret over there, add those credentials manually, and you need to enable the, if you need a automatic enable like rotation, you need to enable that rotation as well. Select the corresponding single user or alternate user. We will discuss on what is single user and alternating user later, right? So then you need to save it, right? Basically, if you have selected credentials are managed manually, you need to go ahead and create those secrets in the secret manager in order to handle those secrets. Clear? So let's come back. Let's go to the AWS console now. More of a theory we have understood. Let's do it practical. Let me log in. Okay, so let me go to the service called Secret Manager. So I'm inside Secret Manager. So here there are no other options. I'll just go ahead and create store new secret. As soon as I click on store new secret, you can see these are the options that I mentioned. This is for RDS database, this is for DocumentDB database, this is for Redshift data warehouse, credential for other databases, right? Then manage external secrets if you want to manage this credentials for any external entity, other types of secrets, right? So here, if you can see, if I click for credential for Amazon RDS database, you have the key pairs already listed because it remains the same, username and password. If I click on other types of secrets, you need to manually enter the key and value pair, right? You need to manually enter the key and value pair, and then you need to create it. So let's go on with Amazon RDS itself. So here it shows, like if I select Amazon RDS database, here you can enter your password, username and password. So I would give the username as test, password as test at the rate of 123, something like this. But here, can I go ahead and create this particular credentials? No, because there is no database that I have created over here. I need to also select the corresponding database in order to create this particular secret, right? So let's go to RDS and let's see. Let's create a simple database over here, right? We will discuss on what is RDS, how to configure RDS, how to create RDS, all these things when we move on to RDS. Our focus for today is just secrets, right? I am just creating a database over here. I'm selecting easy create, free tier. I'm selecting a free tier version over here. So here, can you see this option? Credential management. In credential management, you have two options: managed in AWS Secret Manager, most secure, self-managed. Why it is saying most secure? Because your credentials are created and managed by AWS, and that will be stored in your secret manager. Self-managed means you need to manually enter your username and password, and then you need to go back and you need to store them in a secret manager. It's up to you whether you need to you want to store those in a secret manager, but it's always a good practice to, even though if you go ahead with the self-managed, you need to always store your secrets in secret manager, right? If I select this option, let's select this option. Okay, now it says like see, RDS generates a password for you and manages it throughout its life cycle using AWS Secret Manager, right? Username is here, this is the username. It generates some random password and it stores that particular secret in your secret manager. So let's see, let's go ahead and create this particular database, right? It will take some amount of time. Let's wait for it. Okay, so now here you could see that that particular database is available. So let's go back to the secret manager over here, click on secrets. See, so since we have enabled that the secret should be managed by AWS, it has automatically created this particular secret with this particular secret name. If I get inside this particular secret name, here you could see, right? So if I want to retrieve the secret, I can click on this. So this is the username and this is the password which it has created, right? So similarly, if I click on rotation, as I mentioned earlier, see, rotation is enabled, rotation status is enabled, and schedule is for 7 days. By default, it takes a schedule of 7 days, right? If you want to rotate the secret immediately, you can do it over here. If you want to edit the rotation, like, okay, I need to change the rotation schedule, you can definitely go ahead and change this rotation schedule as well, right? So this is how the secrets are created if you go ahead with respect to manage secrets, right? So now this is what I said earlier. So if I want to create, now the database has been created, right? Here I have created a particular database, and this database master credential has been created and it is stored in a secret manager. Now I want to create one more user as part of this particular database, right? If I click on store new secret, so credentials for RDS, now here I can give a different name like Manu, right? And I can give some random password, right? Now here I need to select the database. So if I am selecting a database, it is this particular username and password will be mapped to this particular database. Okay, so if I click on next, okay, if I click on next, I need to give some name. I will be just giving like dev. In the description, we will discuss on all these things later. Then leave all the default parameters as is. Now here you can see configure rotation, and here it has mentioned like option. Like as I mentioned earlier, if you want, you can enable the rotation on the secrets. If you don't want, you need not to. It's an optional field, right? So if I want to enable the rotation on this particular secret, so here I can give a scheduled expression builder like 23 hours, right? After 23 hours, the secrets will be rotated, and here you need to select that particular rotate function. Basically what it happens is, as soon as you select this particular automatic rotate option, you need to give this particular secret will be like, basically it needs to generate a new random secret, right? So it generates this new random secret, right, with the help of lambda function. Sir, should we write a code for this in order to create that particular secret? Need not to, right? Here you can go ahead and just mention the lambda function name, and here you have option of two options over here. One is a single user, the other one is an alternating user. In single user, it says the user must have permissions to update their password, which means that, see, if I don't enable the automatic rotation, nothing will happen. Like it basically creates a username and password, that's it, and that secret will be stored in a secret manager, not on the database, right? You need to, again, if you have stored the secret, does secret manager will automatically create that user in a database? No, you need to go back and you need to create those secrets on the database itself, right? So this is just used to manage. But if you enable this automatic rotation over here, and if you select a single user over here, it clearly says the user must have permission to update their password, which means that on the database, whatever the user that we are creating, like Manu, this particular user should exist, right? Also, this particular user must have permission to update his password, right? AWS will not create this user called as Manu. AWS just logs into this particular database, It creates a random secret with the help of lambda rotate function, and then it updates that particular credentials in the database. Right? So this is for single user. Then what is alternating user? So alternating user means, see, this strategy clones the initial user, which means that whatever the initial user that we have created called as Manu, and stores both sets of credentials in one secret. Right? It basically clones. Cloning means what? You are creating a replica of that particular user. Right? So we are creating a user called as Manu. Right? If I select alternating user, it all, like, while rotating this particular secret, what it does is it creates some clone of this particular user, like Manu underscore clone, something like this. Right? And it stores both sets of the credentials in one secret. Like if you open the secret, you will be having two users over there. One is Manu, the first user. The second one is the user that has been created by AWS by cloning it. Why are we doing it? I will let you know. Right? One set of credentials is always valid, which means that always one set of credentials will be valid, and thereby the connection will not be hampered when your front-end application is trying to access, or your database, like normally that particular user will be used in your front-end application in order to access your database, right? So it will not be hampered. See, assume like I'm enabling the rotation on this particular secret with only single user, right? Now AWS at the background, what it is doing, it is updating the password. At the same point of time, if the user makes a database call, right, and if doesn't happen, or something it breaks because of this rotation, then it would be a TDS issue, right? That too in production, right? So that's the reason at least one set of username and password should be available over there, so that the communication is not hampered, right? During that course of time, you will go with alternate user. So it clearly says that one set of credential is always valid, which means that you have two users now, Manu and Manu clone. So if it is updating the credentials for Manu, Manu clone will be available for your transaction. If it is updating the secrets for Manu clone, right, Manu will be available for your transactions. At single point of time, it updates only one credentials, right? In order to do that, which means that basically if you are selecting alternating user, so AWS is going ahead and it is creating or cloning this particular user, whatever you are given. Like it needs to clone a user, Manu, and it needs to create one more user basically, right? So for that it needs an admin permissions, right? That's the reason it is saying you must provide admin credentials in separate secret. So this is not this secret, like basically this is an admin credential which has the capability of cloning that particular user, right? Which will be used by your secret manager in order to clone this user called Manu, right? So once we do this, we'll go ahead and click next, review it, and we'll go ahead and click on store. So this is how you create users on the database, right? Two things to remember. If you are not enabling automatic rotation, secrets are just lying in secret manager. If you are enabling the secret automatic rotation on a secret manager only updates the password in the database. That's it. So this is all about your secret manager with respect to your database, right? So consider the same steps needs to be followed across different databases that is available in your secret manager, right? So the next, let's move on to the next topic over here. The next topic of interest over here is, the next topic of interest over here is, see, normally if you are going at with respect to secret manager, you will store those secrets in secret manager, and your application should call that particular secret manager and access the secrets from secret manager in order to use those secrets. But what happens with respect to Kubernetes, right? My applications are running inside a pod. Normally in Kubernetes, you will write a manifest file and we will go ahead and create the Kubernetes secrets. Okay, in Kubernetes also there is a concept of secret. When we come into the Kubernetes classes, we will discuss onto it, but this is morely on how we are syncing the secrets from secret manager to EKS, right? So if you are not doing it, if you are assume, let's forget about secret manager now, right? If you are leveraging secrets in Kubernetes, At this point of time, what we will do, we'll go ahead and create a Kubernetes secrets. Right? We'll write some YAML file. You will store those secrets over here. Like you can store different types of secrets. We'll discuss that later. But so once you store those secrets, once you deploy that particular file like kubectl create secret, so the secret will be created in a Kubernetes environment and that can be accessed by your pods. Right? What is the problem with respect to it? Right? So the problem with respect to it is, assume like I need to manually add those secrets in my secret.yaml file and I need to manually create those secrets, which is like if I want to store a secret, basically I need to create a YAML file and I need to store a secret. Similarly, for each and every environment, I need to do the same repetitive task. Right? And also, can I rotate those secrets over there automatically? No, not possible. Right? You need to manually go ahead and rotate your secrets if you want to rotate those secrets. Right? So these are all the issues that we have with respect to our Kubernetes secrets. Then what's the solution? The solution lies in AWS. Like you have a secret manager already, AWS Secret Manager. Try to link your AWS Secret Manager with respect to your Kubernetes environment and automatically create those secrets in the Kubernetes secrets. Right? Rotation will be handled. Your secrets will be secured. Right? It remains same across multiple environments. Right? The process remains same on multiple environments. Right? So here, what we will do is we will leverage the AWS Secret Manager in order to create the secrets on Kubernetes. Right? So first thing is store. As usual, we will go ahead and store the secrets, whatever it is necessary for Kubernetes, right? Like for my application. Then synchronize them into Kubernetes automatically with the help of ESO. Right? External secret operator. Right? That external secret operator, basically, as I said earlier as well, each and every service in AWS is independent of each other. Right? If my EKS wants to go and access the secret manager in order to sync the secret to Kubernetes, basically it needs to have permission. Right? So that is what we are doing over here. We are giving a permission to Kubernetes with the help of IRSA, right? In order to connect to secret manager and then pull those secrets and synchronize those secrets to K8s secrets. Right? So this is an external service secret operator that we'll be leveraging in order to sync the secret from AWS Secret Manager onto Kubernetes environment. Right? So this is as in your interviews, right? So how do you synchronize your secrets from AWS Secret Manager to your Kubernetes environment? So that is with the help of external secret operator. Let's continue. So now the concept is, so we should not create any of the secrets in a Kubernetes directly. Instead, we need to create the secrets on a secret manager and then we need to sync those secrets to the Kubernetes environment. How to achieve this? So let's go step by step. The very first step is create secrets in AWS Secret Manager. Quite simple. Go ahead, create whatever the type of secret that you want and store those secrets in a secret manager that you want to sync to Kubernetes. Second, so as I mentioned earlier as well, see, each and every service is independent of each other, which means that, so EKS, which is a managed Kubernetes service, if it wants to talk to the secret manager in order to sync the secrets onto the cluster, definitely it needs a permission, right? Without permission, it cannot talk to the secret manager. So how do you provide the permissions? With the help of roles, right? So if you have come across an IAM class, so if you have been through that particular IAM topic, you will understand what is an IAM role, what is a policy, how to write a policy, right? What is the JSON structure and everything, right? If you have any queries with respect to it, please do watch IAM class, then you will understand this, right? Then you will understand what is a role. Okay. Now, so we need to create a role, right? Then once we create a role, we need to attach the necessary policy to that particular role and provide that role access to our service account. So it will be able to leverage that role in order to synchronize the secrets onto the Kubernetes environment. So second step is what we are doing is, so let's assume that we have already an EKS setup that has been done, right? We have a cluster in your environment, right? go to the EKS cluster, copy the OIDC URL, right? First thing is you need to copy the OIDC URL, right? So you go to the EKS cluster, there you have an option to copy the OIDC URL, copy that and come back to IAM, right? So in the same IAM class, I also explained you how to create an identity provider, right? We have seen an example of how GitHub would be using the provider in order to connect to the AWS account, right? Similarly, here also we need to create a OIDC provider for one time, right? So you go to identity provider in the IAM, right? So you will save that particular, you will provide the OID OpenID connect, and then you will give that provider URL, right? And the audience would be your STS, right? Which is mainly used to assume the role, right? So once this is created, we will go ahead and create a policy, right? The next thing that you do is create a policy which has access to your secret manager, right? Once the policy is done, next step is you create a role, right? So in that particular role, you'll also assign the same URL. So you know what is a principal section. Principal section mainly corresponds to who is assuming this role. So what is the thing that we need to add over here? It is the same OIDC URL from the TKS cluster, which means that so this particular cluster has access to secret manager, which is defined in the policy section, right? Then we'll attach that policy to that corresponding role, right? So once this is done, right, we'll move to the next step. Again, we have just created a role, right? We have just created a role with the necessary permission sets. Have we assigned that role anywhere in the Kubernetes environment? No, right? We need to assign that particular role. So how do you assign a role? So you can assign a role with the help of service account, right? You go ahead and create a service account over here on the Kubernetes cluster. Again, we'll understand what is a service account, what is external service operator, all these things at the later point of time. I'm just explaining the steps like how you can synchronize the secret, right? So you just create a service account over here, right? In the service account, I am mapping the role that I have created, right? So then one time setup. So in order to basically synchronize those secrets, right? There should be something, there should be some application or someone should basically check the secrets that we have stored in secret manager. If it is updated, it needs to sync it, copy it, and create the Kubernetes secrets in at the cluster level, right? There should be someone who should be monitoring it. Who will be monitoring it and what application that we need to create? It is an external service operator, sorry, external secrets operator, which is called as ESO. It is a one-time activity. Sir, like assume like I am storing a new set of secrets on a secret manager. Do I need to create one more time external secret operator? No, need not to. It is one-time activity for per cluster. If you create one external secret operator, that should be fine, right? Then you would go ahead and create the cluster secret store, right? So once you create this cluster secret store and you map your service account, then you can go ahead and create the external secret. So this external secret will basically talk to your secret manager, copies those secrets, and automatically creates those secrets in your Kubernetes cluster as K8s secrets, right? You need not to manually come and create the secrets that you were doing it earlier, right? You just update the secrets onto the secret manager. Even though if you auto update it, like if you rotate the secrets, automatically it will be synced onto your Kubernetes secrets. The question that will be arise in your interview is, how do you manage the secrets in your Kubernetes cluster or EKS cluster? Can we leverage any external secret manager in order to synchronize the secret in Kubernetes environment? Then you can explain these steps, right? You can tell them with the help of an external secret operator, we could synchronize the secrets that is created in a secret manager onto the Kubernetes environment, right? I know this might be a bit complex at this point of time, but as we move on with the other topics, like once we get into the Kubernetes classes, then you will come to know, or then you will be remembering, okay, how the secrets needs to be flowed in. But this is one capability of secret manager, like how do you handle the secrets in your production grade environments, right? This would be the normal question, right? So yeah, that's it. So if you like this video, please do like, share and subscribe. Thanks everyone.